So today's lecture, we're going to be talking about how to instantiate objects and windows, and then how to pass data around between these various windows. So this is kind of a new concept for our class now, because in the past we've created a window, maybe we've created a separate object, and we've kind of called some different methods, but we never had multiple windows and figuring out how to pass data around between those windows. It's a little bit of a learning curve, and it's something that you'll just have to do a few times before it really sinks in on how you're going to pass data around. The most important thing to remember is that whether it's a class, just like this employee class here, or it's a class behind this window, like EmployeeMenu here, this is just a class. So forget about the fact that it's a window. This tends to confuse people. Just forget about it. It's just a class that can be used like any other object. And if you treat it that way, it'll be a lot easier and make a lot more sense on how you pass data around. So here's a sample application that I've created. I'd just like to walk through it here and kind of explain how it's broken apart so that we can pass data around between the various windows. So before I do anything, let's go ahead and run this application and let's look at what it actually does. So the point of this application was just to create some sort of application that would manage employees. So we're going to create multiple employee objects of this class employee, and then we want to be able to pass those employees around throughout our application. So first, let's click the Manage Employees button. So we've got our main menu. This takes us to another window here. And what this does is this allows us to add employees into our application. So imagine that we had to have an application where there could be hundreds of employees as you're running it, or something like that. You need to be able to edit them. In this case, we're going to be able to add different employees. And there's two different ways I'm going to show you that we can do this. You can do one or the other, and there's other ways, but this is two of the ways that I like to do it. This first way is, if I'm doing this, when I add this employee object here, behind the scenes, there's a list of employee objects that's getting passed around, and each time a new employee object is added to that list. So for my entire application, there's one generic list of employees that every time I add a new employee to it, I just add that object to that list. Over here, in this particular example, where I'm adding a new static employee, so there's only one static list for the entire application, and I'm using static methods to add employee objects to that static list. And so there's different ways to do that. But now notice how I added some data here. Let me go ahead and add another one here and another one here. So now I've added two extra objects to each one. Now I'm going to close this window down, and we're going to go over to this employee report window. So that employee report window is going to use the same data, the same list that I've been using over here. So again, there's a list that's just a generic list of objects that I'm passing around. Over here, there's a generic list, but it's declared as static. So we go to the employee report, and I click this, and you can see it's using that same data. So I had already initialized it to some values, and then I added on two extra employee objects to this generic list that's used throughout my application. Over here, it's doing the same thing, but see here, there's those other two objects that I added to that static list. So it's sort of a global list to the application. Again, I just wanted to show you different ways that you could pass the data around between these various windows. So on the one window, we're adding the objects. The other window, we're displaying them. So we had to pass that data around. So first, let's take a look at our employee class. So this is very standard that you'll see in almost every application where you're going to have an object or a class that mimics a real-world object, and it doesn't have any methods in it. And all it does is have attributes that describe what it is. So you have things like employee, or a person class, or a car class, whatever that is, and just have attributes describing it. So here we've used some auto-implemented properties for the first name, last name, and salary. All pretty straightforward then. Next, we want to come over here to another business logic class that's just going to manage our employees for our application. And in this application, there's two different ways we're going to store our employees. One is I've got this public list called list employees. Now notice that this is a regular object. So we have to instantiate an object of this class, and for each object we instantiate, there will be a single list of employees. Now, in reality, we could instantiate 10 of these, and they would have 10 individual lists. But how we're actually going to use this is we're going to instantiate one object, and therefore there will be one list of employees for our entire application. So we're just using it that way when we instantiate an object from this class. Now another way we could do that is by using a static list. So now remember, with a regular list here, we have to instantiate an object of this class, and we're going to have to pass that class or that object around throughout our application to get access to this list of employees. Because remember, we have that one single object that we're dealing with. Where this, if we create a attribute as static, then this list of static employees exists everywhere. Oh, and I got a spell check there. We'll do that. We'll get it fixed. So throughout my application, there's only one static list of employees throughout because it's static. So remember, by default, there's only one throughout my entire application. And to access this list, we use the class name dot, and then we can access this static property. So there's automatically just one throughout our entire application, because remember, this has nothing to do, we don't instantiate objects in order to access static variables. We just use the class name dot. It creates one for us. Now inside the constructor here, I'm going to go ahead and just paste this down here and get this fixed while we're doing this. So you'll see this, as we instantiate this class, you can see that I'm just going to instantiate the two lists and filling them up with some data. Just all this is doing is just initializing some stuff for us, so we have some data automatically with them. Now here's the main methods that we actually care about. The first method is a public method that belongs to each individual object that we instantiate, and inside of it we can pass in the first name, last name, and salary, and we're just going to add a new employee to our list of employees. So that's this list up here. So we call this public method. We can add a new employee. This public static one, again, we'd say class name dot add new static employee, is going to add an employee to this static list. So two methods that do two different things but have the same logic behind them. Now we also have this create report. So what this is going to do, this one here, it just loops through each employee in our list, creates a string, and returns that string. So it just has all of the employees' information concatenated together so we can print it out. Down here, notice it's a static method, and so it loops through all the static employees and then adds that to a string and returns it. Now if we go back to our main menu here, if we take a look at the code behind it, you notice that here's where we create our object reference to that employee object manager. Here's where we instantiate it. So nowhere else in our application are we going to instantiate another object of employee object manager. Why? Because inside of our employee object manager has this one list of employees that we want to have used everywhere. So that means this object here, if we're going to use it anywhere else in our application, we have to pass it into those other windows. In our application, we have two other windows. So let's look at the first window. So here we go. This is the Manage Employees click. So we're doing with this button here. So first, we're going to instantiate our window to Manage Employees. In this particular example, I've decided to create a constructor for our Manage Employees window that passes in that object that we instantiated up here. So that's how we're passing it into this window, so that this window can use this same object to add new employees to. And then I just show that window to the user. The other one is to actually create the employee reports. So I'm going to instantiate the employee report window. Then what I'm going to do is I'm going to, rather than doing the constructor, I'm going to use a property. So it's just a different way of passing this one object to a window. Either way, I just want to show you the different ways you could do it, and then I show that window. So let's take a look now at these other two windows. So first is the Manage Employees window. So we can add a regular employee object and then the static employee object over here. So you'll notice that we've created an object reference to our Employee Manager class, but we're going to pass in that object in the constructor. So notice we're never using the new keyword in our constructor over here. That's because we're having the object passed in, and that way we're using the same object throughout our application. Now when the user clicks Add New Employee, we use that object that was passed into us, we call the addEmployee method, and we pass in the first name and last name and the salary to it. If we're going to do the static employee, notice here we just use the class name dot add static employee and pass in the same information. See how it's virtually identical, doing it two different ways? And again, there's advantages and disadvantages to doing it both ways. I just always want to show you how to do it both ways. It really just depends on the scenario that I'm using, which way. I kind of try to think through from the beginning, which way will be easier, which way will be easier to maintain, things like that on how I'm actually creating all of this stuff. So the next one over here is our employee report. So just like before, we've got our object reference. This time I've created a property to set that object reference. Then on the create report, we use that object that was passed in via the property, and we can display all of the data. So see how we're using that same object throughout our entire application. We instantiated it one time at the top level, that employee menu, and then everywhere else we're passing in or passing around that employee object so we can use it everywhere else. It wouldn't make sense in here to say this employee, new employee, because that's a brand new object. It's another copy in memory. We only want one in memory. Now over here with the static, you can see I can just say class name dot, and this will print it out. I didn't have to worry about passing around anything that was just an object of the method. So next, let's kind of talk about our math game assignment. And I want to walk through this on how we can use multiple menus and not just pass data around, but how we can actually open and close the windows and how the application can move between windows, closing them down, and go the different paths. So in our math game, there's a play game which takes us to our game menu, which will then take us to our high scores menu. If I close the high scores, it'll take us back to the main menu. If I click high scores, it'll show us the high scores. If I close that, it comes back here. If I click the enter user data, the enter user data window pops up. When I close it, it comes back to the main menu. In our game for math, the user can't play the game until they've entered user data. And so that's why I've set it up this way. So you'd have to figure out, okay, I've got a main menu window, I've got a enter user data window, I've got a high scores menu, I've got a game menu, and I have to figure out how to pass data around between those various windows. Well, that's what the previous part of this lecture was about, how to pass data around. Now I'm going to show you about how to actually just open these windows in a particular order. So let's just go from the main menu to the high scores menu. You can see how it disappears and it shows the high scores. Now if I were to close it here or click the X, you can see it's going to take me back to the main menu. So the user can then play the game or enter user data. Now that they've entered their user data, they can close it or click the X. It'll do the same thing, takes them back to the main menu. Now they can play the game, and so here's where the game's played. Now before they click the start game button, they could always click the X or the end game button. They can come back to the main menu. Or after the game's played, the game's finished, you can go to the high score screen. A high score screen, you can either close it for the X or the button. When I close it, notice how it goes back to the main menu. So let's take a look at how that all works. Now this is Windows Forms. The assignment has to be in WPF, but I want to show you how to do it both ways. So here's our main menu. Now when I'm creating an application like this, I always think of this main window, the menu, the top level window is sort of the driver. I think of it as the master who knows about all the other windows, all the other objects, all the classes, and it's sort of the driver. It's in the driver's seat. That's the way I think of it and how I design out my applications. So one way that I will do it, if this is the scenario that I'm using, is this main menu will instantiate all of my other windows. And if another window needs to instantiate another window, it's actually passed into that window. And that way, I always think of it as this one window is the one that's going to instantiate all my windows. It's going to handle opening them, displaying them, and things like that. It doesn't have to be the way you do it, but that's a way that I like to do it. So what that means is that this main window is actually going to be in charge of these other windows and displaying them. So you'll notice that I create the object reference for each of these three windows, actually instantiate those three windows here. So the logic being that I have this one main driver, main menu window. it will be the only place where I'm actually instantiating the other windows. It's the controller. Now this is just one way you could do it. For example, the high scores form, we could have just instantiated this behind the game window. But again, that's just a different scenario that you could have done. But in this particular instance, because I'm only instantiating the high score form from this main menu, and essentially always trying to keep it in memory, so that way you're not constantly creating new high scores and then deleting them from memory. We're just always using one in memory. What we'd have to do is on our game window, we're going to have to pass in our high scores window. Because remember, we're only going to instantiate it in one place rather than instantiate it behind the game window. Now, behind each buttons, so Command high scores click, you'll notice the first thing that I do is I hide this menu window. Didn't have to do it that way, but it would just stay visible if we didn't have this line of code. But again, just to draw the user's eye and say, just go to this main menu, hide this window. Then you'll notice that I'm going to do a show dialog for our high scores. Now what show dialog means is that when you open that window, it's going to pause on this line of code until the user closes that window. Then it will continue executing on, and they'll have the main window show. So let's run that and show how that actually works. So if I click high scores, you can see it opens this one, and now it's on this line of code right here. It's actually just waiting until I close this down, and then it executes this line of code, and then it continues executing on. So I actually sometimes will like to set a debug point here just to really get this point across. So let's click high scores now. See how it goes to this. Now I'm going to do F10, which means execute one line of code. Now see how it actually is now running the application here, and it's paused right here because it's now executing and waiting for events for the high score window. Now when I close the high score window, notice how it actually jumped back into the debugger and said I can now press F10 and continue on, and it shows the main menu. So that's how that's going to work for us there. Close that down. So now back to our code. Let's take a look at let's do the enter user data. So you'll notice I do the same thing, hide the menu, show the enter user data window, and then show this one again after this one's been closed. Now for play the game, it looks exactly the same, but there's some more that's actually going to happen behind the scenes, because when the code executes right here, it's going to show the game form window. When the game window is done, it's going to do a show dialog to show the high scores window. So when it gets closed, it's then going to go back to the game and then back to here and execute this. And so when we do that, we'll set some more debug points to show you how all that works. Now let's take a look at the user data window. What we've done in here is that when the user clicks that button, all we do is hide this window. And the same thing happens automatically for us if they click the X. And that's only true for Windows Forms. We'll talk about how that works with WPF in just a minute. For our game window, we can either click the X in game or look at the high scores. So here is our property where we're passing in our high scores window, because again, we just instantiated all our windows behind the main menu. If they click in game or that X, we're just hiding the window. If they click the show scores, we're going to hide this window. Then we're going to show the high scores. So now what's going to happen on the main menu is when we play the game and then they click the high scores, it's going to show the high scores, but when you click the high scores, it goes back, it continues executing here, which then takes you back to the main menu. Now let's take a look at high scores. High scores, all it does is when they click that button, it just shows the hide, or again, if you click the X, that happens automatically. So let's run this one more time. Now when I click play game and I click high scores, right here we're actually looking at this code right here. So I'm going to set a breakpoint here, and now I'm going to go ahead and click this close high scores. So see how it does that? Now this is the high scores window, but when I press F10, see how it jumps to the game window? That's because I'm on this line of code right here. But notice how I don't do a show after my command show high scores click, because I don't want to show the game. I want to go all the way back to the main menu. So now this executes past that line of code. Now it's going to jump back to the main menu. See how it was showing me the game, which was then showing me the high scores? And now it comes back to this main menu, and now I continue on, and it shows me my main menu, where the user can now go to the high scores, user data, or play the game again. And so this is how I would start off, how I'd skeleton out the code. I'd make sure the windows are going between each other, and I wouldn't code anything else behind this UI. I would then switch gears and I would go back to the business logic if I didn't already start there first, and I would completely code my game and my user class, then go back and put those behind my UI. So now let's take a look at WPF and how we would do the same sort of game. So if I run this one, you can see it looks very similar. I go to the high scores, I can click the X or click close high scores, enter user data. Same thing, play game, which goes to end game, or close the X, which takes me back to the main menu, or I can go to high scores, which takes me back to the main menu. Exactly the same functionality, but let's take a look how we do this for a WPF now. So same idea, where I'm going to take these three windows and I'm going to instantiate them in my constructor when this main window starts up. My high scores I'm also going to pass into my high scores. My high scores form, I'm going to pass it into my game form via the property. Now this right here I want to point out is something new for WPF. What you'll find is that if you're instantiating a bunch of windows, but the game doesn't quite know that, or the last window running doesn't quite know that those other windows can be destroyed yet, it'll actually keep it in memory, and you'll close down your application and you'll see that you're still in debug mode. If you are, that means that one of these windows has not closed yet behind the scenes, where this can now help that. And what this is saying, okay, for my application, what do you want to set the shutdown mode to? And if we set the shutdown mode to on window close, on main window close, that means when this window closes, force a shutdown of the entire application, even if other windows are still in memory. Again, if you run your application and it doesn't seem to close down when you close the last window, you probably forgot to add this into your code. And I'll show you why we had to create this in just a second for WPF. Now this code down here is going to look extremely similar. So if we're going to play the game, we hide this window, show the game, and then hide the main form, or show the main form again after it's come back. High scores and the enter user data are exactly the same. Let's go over to our enter user data. If we come here, this is exactly the same, where we click that button to hide our window. Now in WPF, it's actually different for when we're trying to just click the X to close our window. So what I had to do is on our window, I had to handle the window closing event. And you can do that. You can just come over here and you can handle this window closing event. That's how you get that going there. And so what happens is when they click the X, it runs this method here. Now this happened automatically for us in Windows Forms, but how the memory works in Windows WPF is slightly different. When we click the X, it actually destroys the object in memory. It disposes of it automatically for us. And that would create a problem over here if the user closes down the window and then tries to display it again. Because notice how we've only ever instantiated this window one time. So if I click that X and this actually destroyed the memory, the next time through you'd get an exception because this window doesn't actually exist in memory anymore. And that's what happens with WPF. If you were to click that X, it actually destroys it in memory. So when you opened it again, you'd get an exception. So if we don't want to actually destroy the window, what we have to do is handle the closing event. We hide this window, but then we say e.cancel equals true. Well, e is this cancel event argument object over here. And when we set e.cancel equal to true, that says, hey, stop this event handling. Like there's other events that would actually, or other methods that would get called after this that would destroy that Windows object, but we're saying don't do that. Just this is the last thing to do, just like this here. Just hide the window, and that's what we're saying here. Don't actually destroy the object. Now over here behind the game window, you'll see here's where we pass in the high score window. We can click that button and then to close the game or to go back to the main menu, and all we do is hide it. If the game is finished, we hide this window and we show a dialog for the high scores, just like we did in Windows Forms. For Windows closing, we do that same code, this dot hide, but again we had to handle the window closing event, so we can say this cancel equals true. So back over here you can see I'm handling the closing event on this window. On high scores, it's going to look exactly the same as the user enter data one. If they click the button, we can just hide the window. If they're going to click the X, then we have to say this dot hide and then cancel this. So when we run this now and we click play and then we click high scores, and now when I close this, it goes all the way back to the main menu, and we now can then go start quoting our business logic and then implement it here into our UI. This lecture does cover a lot, and it's a bit of a learning curve, so I just recommend you watch the lecture and then write some sample code and just open code that does multiple windows and passes data around between the two. As you get confused, come back to the lecture, come back to these example programs, and see if you can start getting your head wrapped around them. If you have any other questions, just shoot me an email.